Article 430.102b states that means shall be provided for disconnecting the heater from all ungrounded conductors. Article 430.102c specifies that the disconnecting means for duct heaters shall be located at the point of connection to the duct and shall be within sight of the duct heater. There is an exception. Disconnecting means shall not be required for duct heaters within the casing of a fan unit. Based on the NEC, a disconnect that is not within sight of the duct heaters and not readily accessible does not satisfy the requirement for a disconnecting means for duct heaters. The disconnect should be readily accessible to allow for servicing and emergencies. If the duct heaters are not within the casing of a fan unit, a separate disconnecting means is required. The disconnecting means should be labeled to indicate its purpose. This ensures that anyone working on the duct heater can quickly and safely de-energize the circuit. The location of the disconnecting means is crucial for safety and efficient maintenance. Firstly, having the disconnect within sight of the duct heater allows for immediate verification that the correct circuit has been de-energized before any work begins. This reduces the risk of accidental electrical shock. Secondly, readily accessible means that the disconnect should be easily reached without the need for tools, ladders, or moving other equipment. This is important for quick response during emergencies. The exception for duct heaters within the casing of a fan unit recognizes that these heaters are often integrated into a larger piece of equipment where a separate disconnect may not be practical or necessary. However, even in these cases, the fan unit itself should have a readily accessible disconnect. Labeling the disconnecting means is another important safety measure. The label should clearly indicate which duct heater the disconnect controls. This prevents confusion and ensures that the correct circuit is de-energized. In addition to the NEC requirements, it is also important to consider any local codes or regulations that may apply. These codes may have additional requirements for disconnecting means, such as specific types of enclosures or grounding requirements. It is always best to consult with a qualified electrical inspector to ensure that the installation meets all applicable codes. When selecting a disconnecting means for a duct heater, it is important to choose a device that is properly rated for the voltage and current of the circuit. The disconnect should also be suitable for the environment in which it will be installed. For example, if the duct heater is located in a damp or corrosive environment, the disconnect should be rated for that environment. Regular inspection and maintenance of the disconnecting means is also important. This includes checking for any signs of damage or corrosion and ensuring that the disconnect operates smoothly and reliably. Any damaged or malfunctioning component should be replaced immediately. Proper installation and maintenance of the disconnecting means is essential for the safe and reliable operation of duct heaters. By following the NEC requirements and best practices, electrical professionals can minimize the risk of electrical shock and other hazards. Understanding the specific requirements for disconnecting means in Article 430 of the NEC is crucial for ensuring electrical safety in HVAC systems. The requirements emphasize the importance of having a readily accessible and clearly labeled disconnect within sight of the duct heater to facilitate safe maintenance and emergency shutdowns. The exception for heaters within fan units provides some flexibility but still requires a means of disconnection for the entire unit. Staying compliant with these regulations protects both service personnel and the integrity of the electrical system. Let's delve deeper into the reasons behind each requirement and their practical implications. The NEC mandate that the disconnecting means be within sight of the duct heater is primarily a safety measure. It ensures that the person working on the heater can visually confirm that the correct circuit is de-energized before starting any work. This direct line of sight reduces the possibility of accidentally working on a live circuit, which could result in serious injury or even death. Imagine a scenario where an electrician is tasked with repairing a duct heater. If the disconnect is located in another room or on a different floor, the electrician would have to rely on verbal communication or a circuit directory to identify the correct breaker. However, these methods are prone to error. Someone could accidentally switch the wrong breaker, or the circuit directory could be outdated or inaccurate. By having the disconnect within sight, the electrician can physically verify that the correct circuit is off before touching any wires or components. This simple visual confirmation adds an extra layer of safety that can prevent accidents. The requirement for the disconnect to be readily accessible is also important for safety and efficiency. Readily accessible means that the disconnect should be easily reached without the need for tools, ladders, or other equipment. This allows for quick and easy de-energization of the circuit in case of an emergency. For example, if a fire breaks out in the ductwork, someone can quickly shut off the power to the heater to prevent further damage. Similarly, if an electrician needs to troubleshoot a problem with the heater, they can easily de-energize the circuit without having to search for a hidden or inaccessible disconnect. The exception for duct heaters within the casing of a fan unit recognizes that these heaters are often integrated into a larger piece of equipment. In these cases, it may not be practical or necessary to have a separate disconnect for the heater itself. However, the fan unit as a whole should still have a readily accessible disconnect that can be used to de-energize the entire unit, including the heater. This allows for safe maintenance and repair of the fan unit without having to disconnect the heater separately. Labeling the disconnecting means is another crucial safety measure. The label should clearly indicate which duct heater the disconnect controls. This prevents confusion and ensures that the correct circuit is de-energized. For example, if there are multiple duct heaters in the same building, each disconnect should be clearly labeled to identify the corresponding heater. The label should be durable and easy to read even in low light conditions. In addition to the NEC requirements, it is also important to consider any local codes or regulations that may apply. These codes may have additional requirements for disconnecting means, such as specific types of enclosures or grounding requirements. Some jurisdictions may also require that the disconnecting means be lockable to prevent unauthorized persons from re-energizing the circuit while work is in progress. When selecting a disconnecting means for a duct heater, it is important to choose a device that is properly rated for the voltage and current of the circuit. The disconnect should be able to safely interrupt the maximum fault current that is likely to occur in the circuit. The disconnect should also be suitable for the environment in which it will be installed. For example, if the duct heater is located in a damp or corrosive environment, the disconnect should be rated for that environment. This may require the use of a special enclosure or corrosion-resistant materials. Regular inspection and maintenance of the disconnecting means is also important. This includes checking for any signs of damage or corrosion and ensuring that the disconnect operates smoothly and reliably. Any damaged or malfunctioning components should be replaced immediately. Proper installation and maintenance of the disconnecting means is essential for the safe and reliable operation of duct heaters. By following the NEC requirements and best practices, electrical professionals can minimize the risk of electrical shock and other hazards. In conclusion, the disconnecting means requirements for duct heaters are designed to protect workers and prevent accidents. By understanding these requirements and following best practices, electrical professionals can ensure the safe and reliable operation of HVAC systems. Furthermore, it is crucial to understand the implications of these requirements in real-world scenarios. Consider a large commercial building with multiple HVAC systems and numerous duct heaters. Each duct heater must have its own disconnecting means that is readily accessible and within sight of the heater. This can pose a challenge in terms of space and logistics, especially in older buildings where the electrical infrastructure may not have been designed to accommodate these requirements. In such cases, it may be necessary to relocate or add new disconnecting means to comply with the NEC. This can be a costly and time-consuming process, but it is essential for ensuring the safety of workers and the proper functioning of the HVAC system. Another challenge arises when duct heaters are located in concealed spaces, such as above ceilings or behind walls. In these situations, it may be difficult to meet the requirement that the disconnecting means be within sight of the heater. One solution is to install an access panel that allows workers to view the heater and the disconnecting means from a safe distance. The access panel should be clearly labeled to indicate the presence of electrical equipment. It is also important to ensure that the access panel is readily accessible and can be opened without the need for tools or ladders. In some cases, it may be necessary to install a remote disconnecting means that is located in a more accessible location. The remote disconnecting means should be clearly labeled to indicate that it controls the duct heater in the concealed space. It is also important to ensure that the remote disconnecting means is properly wired and grounded to prevent electrical hazards. The exception for duct heaters within the casing of a fan unit can also present challenges. While this exception allows for some flexibility, it is important to ensure that the fan unit as a whole has readily accessible disconnecting means. This means that the disconnecting means should be located in a place where it can be easily reached without the need for tools or ladders. It is also important to ensure that the disconnecting means is properly labeled to indicate that it controls the entire fan unit, including the duct heater. In addition to the NEC requirements, it is also important to consider the specific operating conditions of the duct heater. For example, if the duct heater is located in a dusty or corrosive environment, it may be necessary to use a disconnecting means that is designed to withstand these conditions. This may require the use of special enclosure or corrosion-resistant materials. It is also important to consider the ambient temperature in which the disconnecting means will be operating. The disconnecting means should be rated for the maximum ambient temperature that is likely to occur in the location where it is installed. This will prevent the disconnecting means from overheating and failing. Regular inspection and maintenance of the disconnecting means is essential for ensuring its continued reliability. This includes checking for any signs of damage or corrosion and ensuring that the disconnecting means operates smoothly and reliably. Any damaged or malfunctioning component should be replaced immediately. It is also important to test the disconnecting means periodically to ensure that it is functioning properly. This can be done by using a voltmeter to measure the voltage on both sides of the disconnecting means when it is in the open position. If there is any voltage present on the load side of the disconnecting means, it indicates that the disconnecting means is not properly interrupting the circuit. In this case, the disconnecting means should be replaced immediately. Proper installation and maintenance of the disconnecting means is essential for the safe and reliable operation of duct heaters. By following the NEC requirements and best practices, electrical professionals can minimize the risk of electrical shock and other hazards. In addition to these technical considerations, it is also important to emphasize the importance of communication and coordination between different trades and contractors. For example, if an electrician is installing a new duct heater, they should coordinate with the HVAC contractor to ensure that the disconnecting means is properly located and labeled. Similarly, if an HVAC contractor is performing maintenance on a duct heater, they should coordinate with the electrician to ensure that the circuit is properly de-energized before any work begins. Effective communication and coordination can help to prevent accidents and ensure that the work is completed safely and efficiently. It is also important to provide adequate training to workers on the proper procedures for working with duct heaters and their disconnecting means. This training should cover the NEC requirements as well as any specific safety procedures that are in place at the job site. Workers should also be trained on how to identify potential hazards and how to respond in an emergency. By providing adequate training, employers can help to ensure that the workers are able to work safely and effectively with duct heaters. In conclusion, the disconnecting means requirements for duct heaters are a critical component of electrical safety. By understanding these requirements and following best practices, electrical professionals can minimize the risk of electrical shock and other hazards. It is also important to consider the specific operating conditions of the duct heater and to provide adequate training to workers. By taking these steps, electrical professionals can help to ensure the safe and reliable operation of HVAC systems. Also, consider the electrical system design. The electrical system must have overcurrent protection to protect the conductors from excessive current per NEC Article 240.4. The overcurrent protection device protects the conductors from overload and short-circuit conditions. The size of the overcurrent protection device is determined by the ampacity of the conductors. The conductors must be sized no less than 125% of the duct heater's full load amps, per NEC Article 430.22a. The disconnecting means must be horsepower rated if it is used as a motor controller, according to NEC Article 430.110. The disconnecting means is also required to have an ampere rating of at least 115% of the full load current of the duct heater, per NEC Article 430.110a. The equipment grounding conductor must be sized according to NEC Table 250.122. The equipment grounding conductor connects the metallic parts of the duct heater and the disconnecting means to ground, providing a low impedance path for fault current to return to the source, tripping the overcurrent protection device. Duct heaters are often used in conjunction with thermostats, which control the temperature of the air being heated. The thermostat must be properly wired and installed to ensure that the duct heater operates safely and efficiently. The thermostat should be located in a place where it can accurately sense the temperature of the air. The thermostat should also be protected from physical damage and tampering. Duct heaters can also be used in conjunction with other HVAC equipment, such as air conditioners and heat pumps. When duct heaters are used in conjunction with other HVAC equipment, it is important to ensure that the equipment is properly integrated and controlled. This will help to ensure that the HVAC system operates safely and efficiently. In addition to the technical aspects of duct heater installation and maintenance, it is also important to consider the environmental impact of these systems. Duct heaters can consume a significant amount of energy, which can contribute to greenhouse gas emissions. Therefore, it is important to select energy-efficient duct heaters and to operate them in a way that minimizes energy consumption. There are a number of ways to improve the energy efficiency of duct heaters. One way is to use a variable speed fan motor. Variable speed fan motors can adjust the airflow to match the heating demand, which can save energy. Another way to improve the energy efficiency of duct heaters is to use a programmable thermostat. Programmable thermostats can be programmed to automatically adjust the temperature based on the time of day and the day of the week. This can save energy by reducing the amount of time that the duct heater is operating at full capacity. It is also important to properly maintain duct heaters to ensure that they are operating efficiently. This includes cleaning the heating elements and the fan blades regularly. Dirty heating elements and fan blades can reduce the efficiency of the duct heater. By taking these steps, electrical professionals can help to minimize the environmental impact of duct heaters and to ensure that they are operating in a sustainable manner. The NEC contains many articles, tables, and sections that correlate and refer to each other. It is important to review the NEC for the year that the project is being engineered and installed. The authority having jurisdiction, or OJ, is the final decision maker on all installations.